How functional programming handles null pointer exceptions. Imagine a world where bugs caused by null values simply vanish. Sounds like a dream, right? Well, in the realm of functional programming, this dream becomes reality by changing how we think about missing or undefined data. Instead of relying on nulls, functional programming uses safer tools to handle absence explicitly. This approach makes code more reliable and easier to read. One of the main tools is called an optional type or maybe type. Think of it as a container that either holds a value or indicates that no value exists. This makes it clear when data might be missing, so programmers are forced to handle that case. For example, if a function returns an optional, you have to check if it has a value before using it. This prevents errors that happen when trying to access data that isn't there. These optional types follow principles similar to what are called monads in functional programming. They wrap the possibility of absence and give you methods like map and flatMap. These methods let you transform or chain data without ever directly dealing with nulls. So, you can perform multiple operations safely, knowing that if a value is missing, the chain stops gracefully. Using optional types encourages developers to handle missing data early, during coding, not later when bugs appear. Functions return optional instead of raw data that might be null. When calling these functions, you must decide what to do if the value is absent. You might provide a default, throw an error, or handle it in some other way. This makes your code safer and more predictable. In traditional programming, null pointer exceptions happen when you try to access a null value. But in functional programming, by avoiding nulls and using optional types, these errors are eliminated by design. It shifts the responsibility from runtime checks to compile time safety. This means fewer bugs and easier debugging because you know exactly where and how missing data is handled. So, in short, functional programming handles null pointer exceptions by not using nulls at all. Instead, it uses explicit containers that representing optional data. This forces you to handle every case where data might be missing, making your code more robust from the start. It also simplifies debugging because potential null errors are caught early, not after the program runs. That's how functional programming keeps bugs at bay and makes your code safer and cleaner.